guide here on the basics that one needs to at least know to say that you know something about TypeScript. Can you see the screen?
Yeah.
Yeah. So we'll start with what is TypeScript. So yeah, you can ask a question. You can just interrupt me whenever and ask any question if something is not clear. So basically, they say that TypeScript is a superset of JavaScript. You'll hear someone say superset of JavaScript. So what does a superset mean? Basically, like it builds on top of JavaScript. That's what a superset is. So yeah, it's basically just JavaScript with a type system. TypeScript adds something called a type system, whereby we have static types for traditionally untyped variables in JavaScript. Yeah, so basically that's what is TypeScript. A superset of JavaScript that adds a type system. What are types? The types of variables. In JavaScript, we don't have types. Like JavaScript is a dynamically typed language. Basically, a dynamic language. Dynamic. We have dynamic and static type languages. Dynamic language, like the types are determined during runtime, like after you've deployed your application. Types checked in runtime, and this is a key cause of bugs in JavaScript, because basically you can just combine types however you want and you won't get like errors. But when that code is executing in production, if there's a type mismatch, you might get a production error that you didn't know of while you are doing development. And then you have statically typed language. Statically typed languages. It's not only JavaScript, we have many. It's not only TypeScript, we have others. Yeah, so basically with static typing, we have compile time, type safety. Like types are checked during compile time. Like when you're compiling your code before you like deploying it to production, that's when the types are checked. And if there's a mismatch, you can configure maybe your CI to fail, to make that build fail, so that you don't deploy an application that is not type safe. Basically, being type safe means that like it's properly typed. There's no place where you are maybe adding a string to a number or trying to access like a string using methods that are for numbers, for example. Yeah, so uh, TypeScript is from Microsoft, by the way, just to mention it. So it basically has a lot of support, and it will continue like because of the resources available to it. It will keep on becoming better with time. Okay, so we've talked about compile time type safety. Because it's compile time, it automatically means you have a compiler. So TypeScript has something called TSC. In full, it's called the TypeScript compiler. And how do you install this compiler in your computer? You basically just need to have Node installed. It's just a package. How do you check if you have Node and npm node dash v? This is here. I have version 18. Yes, you can also check if you have npm. I think it's also dash v. I have version 8. So if you have these two Node and npm, you can basically install TypeScript How do you install it? It's npm I TypeScript -g. Basically, -g is you want to install it globally, but I already have it. How do you check if you have it installed? Just say tsc -v. I have TypeScript version 4.9.5. Yeah, so that's a quick rundown on how to install it and how to check if you have the necessary packages to install to use it or to install it. So this TypeScript compiler is what converts your JavaScript code to TypeScript. I just forgot to talk about the extension. So in TypeScript, for JS, we have .js. When you're normally writing JS, it can be .mjs. I think you've also seen something like this, MJS. If you are using maybe, is it CommonJS or CJS? If you're using modules, MJS and CJS, I think there's something like that also. If you've done a bit of Node. But for TypeScript, we have .ts. So if you want to create a TypeScript file, you basically give it a name and then .ts. For example, here notes.ts. It's a TypeScript file. Then, if you're doing like React, you'll come across also .tsx. This is a TypeScript alternative to JSX. Let's just write the JavaScript .jsx. Yeah, basically we have these extensions. If you're writing a component in React using TypeScript, you'll name it .tsx. But if you're just writing plain TypeScript, as you would write plain JavaScript, you name it .tsx. Okay, let's continue. Let's now go through basic types. Well, actually, if anybody has a question up to there, this is your chance.
Yeah, like you can still use .js or .ts in React, right? Like it will still work.
Yeah, in React it will still work .js or .ts, but I prefer using .jsx just to be a bit more specific on what you're writing, because those files you normally do a combination of JavaScript and JSX. Also, if you name them JSX and like it will give you that a very nice like icon. I don't know if maybe index.jsx. You see, like it gives you a very nice. Actually, that's one of the reason why I name mine JSX. I like seeing this nice icon here. Yeah, so that's a small detour, but you can use either. If there's no other question, we can now jump right into basic types. Let's create another file where we write some code, main.ts. So JavaScript, like TypeScript is basically JavaScript with types. So valid JavaScript is valid TypeScript. That means you can start writing TypeScript today, because as you learn, you just write plain JavaScript. But now the difference between TypeScript and JavaScript, we have this TypeScript compiler, this TSC. So TSC is basically like a teacher. As you write your code, he's marking and looking at this code. Is this code going to cause some errors or not? And most developers don't like that. Like you can get those red squiggly lines everywhere in your code, and like you feel intimidated and you say, TypeScript is not for me. Let me just go back to JavaScript. That's what I felt when I tried it at the first time. Like you don't like to see errors by nature, but yeah, those errors are useful to prevent you from like to check bugs and also to prevent you from creating other types of bugs because of maybe type mismatches. Okay, so let's look at basic types. Basic types. So let's start with you can just create a variable. First name, first and VS Code. VS Code actually, even if you're writing JavaScript, it still has like TypeScript. So sometimes you see you have auto completion. I think even if you're using JS files, that's the power of TypeScript. But now if you just dive into like now TypeScript, it write all your code, you'll even now leverage the full power of the language. So in your VS Code, if you hover on a variable, you'll see this thing here. Basically, this is a type. This is a type. So Jen is a type. Yeah, let's make it let first. I'll talk about the difference later on. If you do let, first name is a, you get even if you're writing JS, I think you can, if you go on your variables, you'll see this. You'll get the name and then this thing. This is a type. So that's a string type. You can like the compiler. There's something called um, implicit type type checking and explicit. You can be explicit in your types, but also the compiler also, if you define a variable and assign it something, it is intelligent enough to know what this variable type will be based on the variable that you put here. If you put a number, for example 0, and come and hover, you'll see that now it's a number. So this is implicit typing because the compiler is doing it for you. But you also have something called explicit typing where you explicitly assign the types. And as you can see, I already have a squiggly line. If I hover on that line, I'm told type number is not assignable to type string. Now that is the power of the TypeScript compiler coming in, because I've said that this variable is a string and I'm trying to assign it to a number. But if I come in and say gen, automatically the TypeScript compiler is happy and the squiggly line goes away. So as we know, like the browser does not understand TypeScript. So let's assume you've written some TypeScript here. Let's just say hello. First name, something like that. So this is a TypeScript code. As you can see, it's basically just JavaScript. But now you want to convert it to TypeScript. What do you do? So this TSC, this compiler can do the compilation for you. You basically just have to write TSC, the name of the file. In this case, it's main.ts. And then enter. And then now the compiler will go in and convert your TypeScript to JavaScript. As you can see, this file has just appeared from nowhere. And as you can see, like, let's close that one. As you can see, it's basically what we had here, but we have var here. So TypeScript has the ability to like generate JavaScript, different versions of JavaScript. It can generate, maybe for example, ES5, ES3, it can generate ES20, depending on what configurations you give it. But now the plain, if you're using it just plainly like this, it will by default convert it to ES5. So let's write maybe something in ES6. Someone to, what's some maybe literals. Let's do, but that will not show us properly. But because it's not a feature in ES5, so it will basically convert it to something different. TSC main.ts. Yeah, that's Jen. Let's add something different so that yeah, this is not like what is a feature in ES6 that we can use. Maybe something like this structuring const numbers array equals to 1, 2, 3, 4, 5, 6. So let's say I want to use the rest operator to get and the rest of these numbers. You can say const first and rest is equals to numbers array. This is basically JavaScript, but now it's JavaScript ES6 and console.log first and then rest. So this is a feature that is not there in ES5. So the compiler will figure out how to implement this code to something that is compatible with ES5. Let's see what it does. Yeah, you see, it's basically using how you will do it in ES5. Yeah, so here it's just selecting the first one, and then the rest is just a slice from index one to the last. So yeah, the compiler does that for you, but this is not the default. This is the default behavior if you don't have a configuration. For now, we'll also look at the configuration later. If you add the -w flag, it will, instead of keeping to running like tsc main.ts, it will watch our files and just automatically create the JavaScript. Okay. So yeah, as you can see, we have issues here. If you hover on first name, it's telling you that the variable has been pre-declared. Who can guess why this is happening? Looking at this code here and what has been generated here, who can try to guess what's happening? Why are we getting errors here? Look at that error. Redeclared, cannot redeclare block scope variable first name. First name has already been declared. You can't declare it again. Who can try like to guess what's happening here? Why is it telling us that it's already been declared?
Because it is also in the main.js file.
Yeah, nice attempt. Basically, it's because variables are global scoped, and we also have var here. But now that's where configuration comes in. How do you configure TypeScript? If you want to create a configuration file in TypeScript, you also have a command for that. tsc dash init. And then the compiler does it for us. Created a new TypeScript JSON with target now is ES6 module, CommonJS, straight true, and these other rules. Where is that file? You can go and look at it. Here it is. tsconfig. It's called tsconfig. So it contains like basically settings that you can put in to configure the compiler however you want it to behave. For example, here, this is the target. This is what will be generated. When we use TSC, then the file name, it was generating ES5. But now if you create the tsconfig, it will generate ES6 by default. Let's try to see the difference between the two. So let's close this one. But like basically, this is just bare bones. You don't need to configure it yourself. You can just use Vite, like to create a TypeScript project with a bundler behind it. I just wanted to show you guys like the bare bones, so that when you hear about the TypeScript compiler, you automatically know what someone is talking about. Yeah, it's still generating ES6. Okay, let's just go through the config file. So as you can see, you can set up different things in this file, and we have helpful comments to tell you what something is all about here. All TypeScript projects will have this tsconfig, all of them. It's basically what tells the compiler how to behave. Modules, you can also like create, select, and as you can see, one of the key features in TypeScript, because of type safety, you automatically know all the options that can go into this thing. Like if I put something else, the compiler will just add a squiggly. It's telling me value is not accepted. This is TypeScript now. Valid values, because we already have like types that have been defined for this particular field. If you do control and space bar, you'll see what is supported here. So these are all the module systems that can be supported. It's CommonJS by default. And as I was telling you, the targets, you can go to as soon as ES3, ES5, ES6, ES next, all these. Yeah. Let's get back to now then basic types. So we've talked about the string type. How do you define a string? In JavaScript, this will be, we don't annotate types. This is called type annotation. When you add a type at the end like that. So this is a string type. What is the other basic type? Boolean. Just same. Maybe let this admin equals to false. So the compiler will implicitly type it for me as Boolean. This is the type. If I wanted to do it explicitly, when you're learning, actually, you should also always do it explicitly. I just add it like that, Boolean. If I come and put anything here other than a Boolean, automatically get an error here. Type number is not assignable to type Boolean. Let's pick this code and put it here, assuming you're just writing JavaScript. Automatically, I'm getting an error on the type because it's main.js. You see, the browser doesn't understand types. It's basically, but if I do this, is admin is equals to 9, then I come and say is admin is equals to gen. I'm not getting any errors. If I take this same code, even without types, and I come and write it here, you automatically get those squiggly lines. The TypeScript compiler is watching your code as you write it, and it's giving you very helpful errors. Type string is not assignable to type Boolean. But if you are doing JavaScript, as you can see, it was not an error. Okay. So yeah, let's look at this. Let's just say false. And the next type, number. These are just like, it's basically the primitive types in JavaScript. Each primitive type is a type by itself in JavaScript. 29. Automatically, we have implicit typing, number. But as a beginner, you automatically have to always write your types, number. If I go and assign something else to age, it automatically errors out. What is the next? We have null, undefined. So we have null as a type. Maybe const character. As we know, you cannot declare const without initializing it to something. If I hover it, I get a helpful message from the compiler. Const declaration must be initialized. A const must be given a value and declared, assuming that I don't know what value is supposed to go to this. I can just type it as null. Null is also a type, but like it's hard to find someone typing something as null like explicitly like this. Like it's this is very hard to find, but we have something called um, like something that can have multiple types. For example, if you're fetching data and you're returning the data in a promise, when that code first runs, that data will be undefined or maybe null. And then after the promise fulfills, then you have your data. So maybe you can use null in combination with other types. We'll see that. We'll see that when this is not so common. It's not common, but we'll see how now null is used as we go through this small curriculum here. Same to undefined. It's hard. It's hard to find this const constant doors. Like nobody wants it to be undefined. It's hard to see this, but it's still valid TypeScript. As you can see, if I bring it back, the compiler is not complaining. But we'll see how undefined is also used as we continue on null. So we also have this void type. Now void, this is a bit different from what we have in JavaScript because I don't think we have the void keyword in JavaScript, but we have it in TypeScript, and it's normally used as like function return type. You know, for example, this function, let's maybe just create a function. A function that doesn't return anything. A function that doesn't return anything returns void. Like undefined is not, or I'm already getting an error there. And undefined is not like a common type to assign to something. So, for example, this function, it's not returning anything. It basically has this console log. If I move on it, you'll see this particular thing. The type starts from here, going like that. So this is a function type. Function types are a bit not really basic, but they can still be considered basic. Like this syntax, this function type, but we'll get to function type. But as you can see, we have the void here. We have the void here. Yeah, so that's it's also you won't really see variables using void because like yeah, a variable can you won't really see something like this in TypeScript. But basically it's mostly used as a function return type. We'll look at that as we go down. We also have any. So basically any is like any type, you know, like if you want to tell the compiler not to look at this particular type, you just blast any on top of it. Let's look at that at an example. For example, this let age is equals to 29. If we say age is equals to Jane, like a string, we're getting the TypeScript compiler coming in and saying TypeScript type string is not assignable to type number. But if we come here and change it from number to any, automatically our error goes away. Any basically means it can be any type. It can be like this particular variable can be any type. So you can assign it to an object, to a set, to a map, to whichever type. But now it basically defeats the purpose of using TypeScript. But sometimes you might need it in some instances. Yeah, just to make maybe the compiler to calm down and let you write code in case you don't like know the types at that moment. But it's not really advisable for you to use the any type in when writing TypeScript. Let's just define something. Not advisable. Any is equals to whatever. It can be anything. And it won't give you errors. So yeah, this is something to avoid when you're writing TypeScript and trying to give your variables and functions and everything types. Yeah, what else in basic types? We have something called literal types. So you saw that when I said const, let's just say const roles equals to admin. So const, as you know, is constant. It's a constant variable that will never change. So in TypeScript, it's also treated as a, like, the word admin itself is treated as a type. Like, as you can see here, the the type in this particular case, the type is admin. This is the type. What name are these types given? They're called literal types. Literal types. It can be, like, if you use const like this, it will be a literal type. You can also say let roles. It can also be a number like that, but it's saying that a declared block let's say roles 2 is equals to 0. As if we move on it, it's saying number. But I can make this a literal type by doing something called type assertion. I can just say as const. Then if I come, the type is 0. So we have this thing called literal types. This is a good example of it. You can also make literal types using this as const keyword. What else? I think that's the last basic type. So this is the different things here, like from JavaScript, all this up to here is very similar to what we have in JS. But what we have down here now is what is a bit now specific to TypeScript. What is an example of use case for these literal types? For example, to define roles to define roles maybe in a DB. For example, you have roles as admin. Like, you don't want it to be string. I can also just call it a string like this, and it won't give me any errors. But now the type is a string. So basically, these roles can be any string. For example, if it was a let that I can reassign, it's a string. But assuming that I only have maybe 5 types of admins, like maybe 3, like normal user, admin, and maybe an intermediate something. So I can have something like this. If I wanted to define a type for that user, like, instead of saying string, you literally specify what this type is, and it cannot be anything else. It has to be this or this. It's basically or. If I come here, I say admin, I'll still get an error. But now the power of TypeScript, we have a compiler. If you get squiggly lines, just hover on them. It's telling you type number is not assignable to type admin. Am I using it somewhere as a number? But you can also, like, what is here, you can also just bring it to this other side. Where is that? Let's copy this one. I can't find it on my keyboard. Yeah, I think I'm confusing something there. Yeah, but basically this is literal types. Maybe you can maybe, for example, they are in an array. Let's look at that before we got. I didn't want to talk about arrays before we reach them. like the array type. We also have some the array type. Let's comment roles 2. As you can see, it's a string array here. It's an array of strings, but for example, I can do. I didn't want to really talk about the advanced concept, but just to talk about it as const, it changes to be a read-only array. It can only have these two, and it can't have any other anymore, like any other character. So basically, this is more or less like a tuple. It's a fixed length array. Yeah, I think I've debated a bit into some bit of advanced TypeScript, but it's nice also to talk about that. So let's talk about object types now. Or maybe if someone has a question, this is your chance to ask anything about basic types.
Yeah, maybe just a comment.
Mm-hmm.
I can see, like, even from me, from the way I use TypeScript, it's quite intuitive to understand like what you want to use. Because what used to really confuse me was, I think you're about to get into that, like object types. Like, when do you use
Yeah.
type? When do you use an interface?
Mm-hmm. Yeah, we're heading there now.
Yeah, but I hope that the guys are seeing it's just normal JavaScript with some extra hand holding.
Yeah, the type system,
Yeah,
exactly.
yeah. It's not, if you know JavaScript, then TypeScript you should be able to pick it up pretty quick. Yeah, but so far so good. Very, very well done.
Joseph, I was asking, we're
Mm-hmm.
noting that like those literal types, they have to be in uppercase. I've seen you using uppercase.
Like uppercase is basically, I can say it's a convention, and it's like I'm infected from Redux. You know, when you're defining, have you done Redux? Like when you're defining actions, we have something called an action creator. They normally this is the syntax used, but it's not. It's just a preference. You can use whichever case.
Okay.
But this is what you'll commonly see used. Yeah. So yeah, if there's no other question, we can now head into object types. As we know, maybe we can just scroll down. Let's talk about arrays as types now. Arrays, can just copy our array here. How do you define, if you want to explicitly type an array, how do you do it? You have two ways of doing it. You have a fancy way that you can use to maybe impress some lady that you want or some guy that you want. And then you have the simple way. You basically do that. You call the type and then you just add this bracket. This is an array type. This is basically an array of strings. And immediately I'm getting errors from the compiler. If I hover, type number is not assignable to type string. You see, like it's already, but if I was writing plain old JavaScript, I can easily like confuse the types and then get those errors that have and bugs like during production. There's also another way of doing it, but let's just say number so that the compiler stops erroring out. Okay, it's called, like, you use something called a generic. You basically do it like that, and then you specify the type inside. So this and this, basically the same thing, but as you can see, this one can easily impress someone. Yeah, so you can use whichever that you want. But definitely, we still have implicit typing. the compiler will try to determine what type your stuff is, like that. So when you're beginning, you should leverage the compiler by, for example, if you've defined a variable, just hover on it, get the type, copy it, and then just paste it. And then the more you get familiar with the types, then you'll just start writing your own. Interesting enough, we have very many different types, by the way. If we define a regex, someone to give me like a quick regex, even if we do this, is it A to Z? If you hover on it, we have also this type called regexp. How will you know that it exists? But you can easily get it from the compiler, and then now you create your super typed stuff. And this, the beauty of typing is that you automatically get documentation within your code. So let's just create a string, or even this regex. If you do regex dot, you automatically get all everything that you can do, like all the properties and methods that the regex, this regex object, like this regex variable contains. Same with strings. Let me go and just say any. I can also type it as any, but if I do that, like dot, then control, then you press spacebar, I'm not getting any auto completion. So if you hear people saying that like TypeScript helps you get documentation within your code, this is what they're talking about. By just typing something as a number, for example, constrain, maybe let's just, because const can give us unexpected behavior. So string dot automatically get all the methods. Sorry about that. The plane. But as you can see, automatically get all the methods there. The ones that are crossed out are basically being deprecated. So assuming I was in an interview and I've been told that I can't Google, and I know this method, but I can't really pinpoint it. TypeScript basically will give you all the methods in the string. For example, if you're working with strings, value of string, all of them, substring. And the ones that are crossed out, the ones that have a star are the popular ones that popularly used more often. The ones that have a cross, deprecated ones. But as I told you guys, any is the enemy. If I type it as any and then I come and do dot control spacebar, there's no typing, nothing. Yeah, that was a detour kidogo. But as you can see, you can leverage the compiler. Like I can't remember, like even a few minutes after you've done it, I can't remember what the type was, but we have this like that. Like with this compiler, you can write very, very complicated code, but just using it like to help you with the types and everything. Yeah, so this is arrays. Again, I'm getting errors because this our elements are not strings. But if I do that, the errors go away. So basically, you have to keep on satisfying the compiler. If it's giving you a red, you have to go and investigate what's happening there and then fix that, like make it type safe. And if you look at this code, if you remove the types, it's just JavaScript. If you remove these types and this and everything, it's just JavaScript. Like it's nothing different from what you guys already know. Yeah. And as you can see, as we are going through it, our code is being generated. So they say that you can use tomorrow's JavaScript today. I can basically come to my TS config and change the like target to whichever that I want. For example, ES3, and then I come into my TypeScript and I write modern JavaScript, and then I let the compiler do the rest for me. Okay, yeah. So we've looked at arrays. Yeah, I'll come to that, and then we'll revisit arrays again, interfaces and types, and then we'll revisit You can basically use interfaces and types to replace what we have here, but we'll reach that and talk about that also. We also have objects now. That's an interesting one. Let's look at that. TypeScript is basically just all about typing your stuff. Let's define an object. Name, Jen, age 20. Something like classes. Physics. Something like that. This is an object. If you hover on it, TypeScript has already done everything for us. You can just come and grab the type. And then you just come and do it like that. So if I wanted to explicitly type it, this is what it would look like. And as you can see, it's pretty, it doesn't look really good to the eyes. Like, but this is how you type objects. And then now my obj dot, I'll get only what is inside the object. This is where you type your stuff actually, so that you get this auto completion. Imagine you had such a big object, but you'd automatically know what's inside this object. Because you get this. I only have these three things. Yeah, so sometimes you might want something to be optional. For example, I want age to be optional. You'll see a syntax like this, comma, then this. This basically means that the age variable is optional, and if I hover on it like this, now this is what I was talking about, undefined and null. The type is number or undefined. So if something is optional, it means it will be undefined at a certain point. So you can do this, or you can just come and explicitly type it like this. Now this is one use of undefined, like that. So if I don't provide age, that's the error. Age is missing in type. It's supposed to be optional though. Let's see. If it's, yeah, basically that's what it does. But yeah, apparently my compiler is complaining. But you know, we have many rules that I can come and throw in here to make whatever behavior that I want. For a nice one is maybe no null checks. No null. It's called null something. Yeah, strict null checks. This one. If you enable it, the compiler will take an account into account null and defined. You see when type checking. Like, for example, let's enable it. This one. So basically, the compiler will start now looking at null and undefined. And like when you're working with, for example, objects, you might get some values that are undefined in the beginning, and then maybe they get values later on. So this is a good rule to enable when you're writing TypeScript, because null and undefined are also linked to a lot of like bugs, a big amount of bugs, because like of confusing that. So after typing it, if I wanted now to come and now define the properties, if you do control and space bar, you basically get what goes there, and then age is optional. We have that question mark there. Yeah. So this is how you type objects, but we'll see something that was added to the TypeScript language to make this particular typing easier to even to look at, because it's getting a little bit hard to consume. So we've looked at arrays, objects, and optional types. The optional types are the ones that have this question mark. Then we have functions now. Now we'll see where void comes in. How do you type functions? Okay, so assuming we had a method here, say hello. Console.log. Hello. I'm automatically getting a squiggly line because I haven't defined the type up here. If you on it, it tells you type name, string, age, classes, say hello is not assignable to type because it's missing this. So I can just add it here. And then, yeah, it's not returning anything. I can just type it as void to type void. But now I have to do this. So this is a function type. You see? This is basically a function that returns void, that doesn't have a return type. Okay, assuming I was returning hello. Now it's a function that returns a string. That's how you're supposed to type it. And the compiler has it for you. Like when you're beginning, you don't need to know it. You can just leverage the compiler. Yeah. So this is some method. Now let's just create a function called sum. Assuming it takes two numbers, let's just write it as JavaScript, assuming I'm just learning TypeScript. Then it returns A plus B. So you'll see that, say num1 and num2, so that we see that reads quickly. So you can just start with JavaScript and then build up to TypeScript. This is how you'll write this function in JavaScript. But if you hover, I'm told parameter num2 implicitly has an any type. So I told you any is the enemy. And I think we also have no implicit any. This is a good rule to enables error reporting for expressions and declarations with an implied any type. So this will make it even stricter. The compiler will be stricter with the any type because, as I said again, any is the enemy. So for functions, this is how you type the parameters. It's not a string, it's a number like that. So yeah, as again, I can if I want to type this particular function, I can just hover on the sum and grab the type like that. You don't have to do all the work, especially when you're learning. But as you can see, it's pretty verbose. Sometimes you just need to let the compiler do it for you. You don't need to. But basically, this is our type. It's a function. As I saw, you can see it's just a function here. It's a function that takes two arguments and returns a number. Yeah, but this is pretty verbose. Now, I think this is we also have tuples. Let's talk about tuples and then we'll come and refactor this. Let's just leave it as this and refactor also this using additional things that TypeScript gives us. So as since we started talking about this particular topic, we've only been talking about types. I haven't said this is how you do for loops in TypeScript, this is how you do if, this is how you do whatever in TypeScript. Everything is similar to what you do in JavaScript. The only difference is typing your variables, typing your functions, your objects, and everything that you're using. So it's basically JavaScript with a type system. That's it. And then very many tools that are actually a lot of fun to work with. Yeah, so let's talk about tuples. What is a tuple? Tuple. It's not in JavaScript. Tuple, it's an array of fixed length, a fixed length array. Okay? A fixed length array. Like it's an array that has a fixed length. It can't have additional elements in it. So basically, if I say this, I've said that my tuple is an array. Then if I come and I say string, I get errors automatically. Type this is not assignable to type string. So basically, what I'm saying here is that this tuple, it has to be an array with 2 strings as elements. If I provide them, I've satisfied the TypeScript compiler automatically with that. But if I come and add gen, I get an error automatically. Type string is not assignable to type string. So what is a tuple? A tuple is not any different kind of like data structure or whatever. It's basically an array of fixed length. It doesn't have to be 2, it can be 3, and it can also come in with a number. And then I automatically get an error. Then if I come here and add a number, as automatically the error goes away. So basically it's just a game with the compiler. It's like your teacher. The teacher tells you this is wrong. You go and figure out how am I going to correct this. And again, but if I remove this, let's see what TypeScript will infer the type as. You see that, so sometimes TypeScript can get it wrong. If I wanted to create an array of fixed length with 3 characters, 2 strings and a number, automatically TypeScript is telling me it's a union type of string and number array. So now I can come in and add other stuff. 10, it won't complain. 2, 5. If I add an object, it's not complaining also. But the types are a bit jumbled. So yeah, that's a tuple. Whenever you hear about tuples, it's an array of fixed length, a fixed length array. Yeah, so any question up to there? I think we've talked about arrays, objects. This one is not an array. Let's take it. Okujo, but it's JavaScript. It's just an array. Oh, Colin, go ahead.
So what if the array is a mixture of different type?
It's a mixture of different types, and it's not a tuple. It's a tuple.
It just an array like that, like the way you have here a number of strings. What if it's a mixture?
No, so this one.
Yes.
Oh, it's a mixture of what else?
Boolean, true or false. That one.
Like
So
inside
just,
this
yes.
tuple or inside here?
No, inside the tuple.
Inside here. Boolean. So it automatically errors out. But if I come in, I can add it actually anywhere. You don't have to add it at the end. Apparently, you have to add it at the end actually. Let's see if that will work. Yeah, it has to correspond to whatever location it's representing, like that.
Oh, okay.
Yeah, but you can't add anything else to the array because it's a fixed length array.
Okay.
Or a tuple, in other words.
Okay.
Okay, anyone else? You can go ahead. Oh, Ian.
Yeah, maybe to add on to like Pauline's thought process, like the whole point of the way to think about it is when you're doing normal JavaScript, you can have an array that has a mixed type have Boolean value, string value, but now with TypeScript, that's not really the behavior we want. So for you to be able to get that behavior, you have to explicitly tell it that either the array is only strings, only numbers, only Boolean values, or if it's going to become something that has different types of data, then you have to tell it explicitly. So whether you can, like what Joseph did with a tuple or tuple, depending on how you call it.
Yeah,
So that's
but
the strictness.
if we remove this type, I think now this becomes what you guys are talking about, because if you
Yes.
hover on it, it's a like this is the type for it. It's basically an array that can contain a string, a number, or a boolean. If we do it like that, but it's not a fixed length array. Now that's the difference between tuples and these ordinary types of arrays. But you can still have different values in an array like that, and you can still type it like this.
Isn't that a union type?
Yeah, but now we are using it to type this particular array. Like you see what is in the end here,
Mhm.
the
Yeah,
array
the
type.
array. Yeah.
Yeah, so it's basically an array that can have a string, a number, or a boolean. If we come in here, maybe add what have we not said it can contain. Maybe let's remove boolean. Automatically false errors out. It's telling you type boolean is not assignable to type string or number. Yeah.
Yeah.
So, but now this is an array. This is not a tuple, like the way we talked about arrays here. But yeah, that's a nice addition, Ian.
Can you, now that has raised another question, so you can have an array, like you can using like a union type. So like to Pauline's question, can you have an array that can either have a number, a string, a Boolean value, or I don't know, something like undefined without being
Yeah,
a tuple?
but you have to type it. Yeah,
Mm.
like let's go to what we had. Is it forward or backwards? Like now having undefined inside here.
Yeah.
Yeah, if we add it, you can add it like this. Getting an error is not assignable to types, but if you come and add it here as a union type, it'll stop complaining.
Mm.
But this is explicit typing. If you don't put it, TypeScript will type it for you.
Yeah.
Yeah.
Okay. Yeah.
Another question: what advice would you give? You can sure you put the type, or you just leave them in TypeScript as it.
Come again.
I'm asking, with the types, there we have to put like the types before, so that it matches the whatever you're putting to your array. So what if you don't put them? I mean, the advice, would you advise someone to always ensure they put the type, or you can just leave it for TypeScript to do it?
Like it's always better to explicitly type it, because like someone that is coming to look at your code later on will automatically know these are the types, instead of just going and hovering and trying to figure out the types. It's always good to like explicitly type it, in my opinion.
Oh, okay. Thank you.
I guess if there's no other question, because
I have a
time.
question.
Oh, go ahead.
Could you go over the function again? Like how you, yeah, the function.
This function. Okay. Okay, so for the function type, you basically this thing is what is making it look so different. You basically do this. If you have a function, this is the type of a function. And then if it takes any params, you add your params and type them here. Maybe string, maybe param2, number array, and then you have to tell what will it return. It's like just like an arrow function by there basically. What is it returning? If it doesn't return anything, we don't like undefined in TypeScript, so that is void. You'll type it as something that returns void like that. You see, and then let's actually just create a function so that we see the benefit of doing this. So this is the type, but we'll see like a way of making this a bit more readable after we talk about this particular, write this, yeah. So yeah, it's a function. Now this is now the definition of the function. It's returning void here. Let me say it returns a number, or it's complaining because it doesn't have a return. But if I say return 2, it's not complaining. So let's say it returns, let's call this an index, array. It returns num array index. I'm getting errors automatically. I want it to return like the index. Cannot find num array. So it's telling me cannot find num array because I haven't satisfied these types in the function parameters body. So I can basically just come here and say index num array. And then it's telling me like this is what you do when you're writing TypeScript. You use the compiler. It's telling me number as an any. Let's make it a number to make sense that way. Number like that. Now my compiler is satisfied. Assuming now you're using this function, my func, you automatically, if you pass the wrong arguments, even if you don't pass the arguments, the compiler will tell you expected 2 arguments but got 0. This is the compiler. And then when you go down here, it's telling you const my func detects an index that is a number, a num array that is a number, and it returns a number. Basically, it's just being strict with you when you're writing your code so that you don't make like mistakes. So assuming I come in and pass the first argument as a string like that. If I hover, and let's pass in the second one also, maybe we can pass the second correctly. Again, the compiler is at me and it's telling me what argument of type string, not assignable to type number, because of what I typed here and the type that I specified here. But if I give it a number, it stops erroring out. So basically, when you're typing your functions, this is the type syntax. You specify the arguments. If they are 10, if they are 20, you specify them in this type. This is a type from here going from these semicolons going backwards. You basically specify the types here of your arguments and then what the function returns. If I say it returns void, like automatically it means this function does not return anything. And as you can see, TypeScript is not complaining. Sometimes it's not perfect. It's supposed to complain here because you can't return void, and I'm returning something here. It's supposed to error out. Yeah, but now that is functions, how you type them. I want to reach that place where we make this a bit more readable. Then maybe we can end it at there. Yeah, other types. Let's now talk about other types. Interfaces and type. This is now something that is different to TypeScript. Oh, that's a question. You can just go ahead.
Yeah, and just to maybe point out something, So can you go back to the other code? Was it what where you have the function? I think it's here. Yeah, where you have on line 54. So the myfunc, if we removed the arguments that you're passing in, if you remove them, like now that is valid JavaScript. If you were to run this code in like without TypeScript, you'd find out about this problem at runtime. So when your code runs is when you will see that's when you see the error. You'll still try to operate on it even though there's nothing there. So this is now like a perfect example of how like TypeScript allows you to catch those errors as you're developing your application and compile them. Like right now you're writing the application, so you can see the error before you run the code. So if you did not have TypeScript, you'd not find out about this error until you run the code. That's now where it really helps to have TypeScript. Yeah.
Yeah, that's a good point from Ian. Like, and as we talked about in the beginning, compile time versus runtime. Compile time is when you're compiling your code. So when you're compiling your code, like as you can see here, if I had like a build process, I'm getting one error. The TypeScript compiler is already throwing an error, and I can also come here and configure this compiler and tell it if there's an error, don't emit JavaScript. I think that rule is called emit on error. This one, no emit on error. If you have an error, don't emit JavaScript. Like basically, like if you're doing an application and you have like that CI/CD thing, you can use this TypeScript compiler and tsconfig to like modify the behavior of your code when it's getting errors during compilation. Compile time type safety versus runtime type safety. TypeScript, JavaScript also has types, but they're dynamic. They are determined during runtime, like when you've already deployed the application, and then the errors now start happening if the types were mismatched in one or the other. Let me actually, yeah, that was a nice point from Ian. But now let's move on to experiment with the way it was doing. If I assign it to result, will it give me an error? So you see, the compiler is not perfect, as you can see. Here, I've told it it's returning void, but it's still not giving me errors here. It's supposed to. Okay, so but it's near perfect, so don't worry about it. Let's talk about other types now. Interfaces and type. So this type alias. What's a type alias? Let's start with type aliases. Type alias. What is the syntax? This is the syntax. For example, this function. Where is the dot? Where is it? It was this one. Yeah, this thing is not friendly to look at. If I took it like that, let's just copy the function. Type aliases. So there's something that we called a type. My func. Is equals to. Then we take this thing, paste it here. Then we come here. And then provide it as a type. And then it's giving us error. Yeah, the name my func2. So this is what we call type aliases. You're basically removing the type from the function and throwing it somewhere else. As you can see, now this is a bit more better to read. You see? So this is what is called a type alias. It can be anything, and you can use it to type whatever. You can, for example, if you have an object type, let's type this object using an alias, this one. You can also, let's just copy it. So basically it's there to make your code a little bit more readable. So instead of this atrocity here, you can create another type. And then basically just abstract the whole thing from here and paste it here. And then just come here and say my obj type. So you can basically compose types using type aliases. And then we have something else. They're called interfaces. These are type aliases, and they more or less do the same job with a few differences. So basically, if I wanted to do the same, what I've done up here using interfaces, let's just do this here. They're basically used to abstract away the types, these type aliases and interfaces. Can just come here and say interface. This is the keyword interface. It's just, but they have a bit of different interfaces and like objects. They do like they go like that. And then actually interfaces actually they are, you more or less you'll find that it's very common to type objects, like the shape of objects, using interfaces as opposed to types. So let's use an interface with this. But they more or less do the same type of job. So if we come and hover on my object, it's an object, my object of type, my obj type, and we don't have any complaints from it. So this is an interface, and this is a type. Yeah, so if you have like very long types, it can, like this is just, these are very, very simple examples. It can go even 20 lines, just types. You can just abstract them away. Maybe in a type. Hey, can you hear me?
Yeah, you had broken off a bit, but you're back.
Yeah, I got a call. I got a call for a second. Yeah, so yeah, basically types and interfaces, they perform the same job. But personally, I prefer to use interfaces when I'm typing objects. Then as for types, everything else, for example, the function, an independent function type, but you can still use an interface here. So yeah, what else can we talk about? Union types. Oh, extends. There's a key difference between, but this is a bit of an advanced, but I can just talk about it. You can compose types, like you can create types from several different types. For example, I want to merge these two types here. Let's just comment this one out. Type. Other type is equals to, if I want to merge these two types, I can just say my func. This is it, and this. Then if I hover on it, it's telling me my func and whatever. So basically, it's a union of those two types. You can do the same. This is called type intersection. Intersection types. They're called intersection types. but it's a bit advanced. But I wanted to talk about them because of something that happens with interfaces that is very similar to how we did OP that like the other day. If, for example, let's talk about extending interfaces. Assuming I had two interfaces, and string age number, and they had another interface student. So basically, they're very nice to use when you're working with object interfaces. That is number. If I want, for example, just assume we have like 20 types here and 20 types here. If I want to create one type from these two, I can say interface users student. Interface users extends student, like that. Like this extends, it's a thing in TypeScript, just the way that we use it in JavaScript. So you can use extends also, like that's a key difference between. For this type, you use this intersection if you want to combine types. For interfaces, you can create another interface by extending another interface. Like you can create a combination of 2 or 3 interfaces by just like 2 interfaces by extending the other one. Yeah, so basically, yeah, that's the question. Go
Yeah.
ahead, you.
So from what I'm understanding, you can only store like the interface type is mostly for objects. Can you like give it like a union type, like the way you can with what is it called, the type?
Like this intersection, the and like this.
Yeah. So for example, like if I wanted to have a type called product ID, for example. So maybe you can write product ID, type product ID. So you know the way that when you talking to a database, you have a product ID. So type product ID, and then I want to set that equal to either a number or a string.
Like that.
Yeah, like that. It doesn't have to be like like an object. It can be any other type. Can you like do the same thing with an interface? Can you like give it like other values other than objects?
Yeah, you can. Just a second. I'm trying to send something. Yeah, let's try and see that. For example, like an intersection of these two. But now it will be a bit different. Product ID 2 is equals to. Now you'll have to define the thing inside here. Maybe product. But as you can see, it's pretty nice with objects. That's why I said I normally use it with objects. This is the error here, because it has a very, very similar syntax to objects. So I use this one, for example, if I want to create this like a union of 2 basic types or 2 just normal types. But this one I normally use it with objects and arrays. For example, if I have an array of objects, I can use an interface to define the shape of that object, and then you can just use this syntax. Where is it? The array, this one, and then you just drop the interface inside here. That's called generics. This is a generic, but it's a bit of an advanced concept. Generics are basically like if you want to create like more or less like functions that create types for you. like that output types. It has a syntax that's very similar to functions, whereby like instead of specifying a string here, you can specify something like t, some sort of like what can you call it, like a parameter, like a function parameter, but now it's a type parameter. And then now maybe I can come in here and say t, just like to make it a little bit more, instead of specifying the type itself, you specify it as a generic, so that you can throw in something like I can make it a string array, I can make it a number array. Basically, these represent the whatever type will come in here later on. But that's a bit complex. We'll maybe look at it next time. Yeah, I think we've already talked about implicit versus explicit types. Implicit types are the types that you don't specify the types yourself. For example, if you just come down here and say const age is equals to 10. I already have age somewhere. This is implicitly typed, but as I told you, const will type it as a literal type. Can use let. Yeah, this is implicit type because the compiler implicitly determines the type for you. But we also have explicit types, and we've been doing explicit types all along. This is explicitly typing stuff. This is explicit typing. This, like specifying the types by yourself, and it's recommended that you do that, like as a beginner. And then what else? Oh, yeah, I wanted to talk about type assertion, but we've already talked about that. Basically, TypeScript, as I told you, sometimes TypeScript is not like, does not have the whole picture. Like, for example, as you as a developer, you might have the whole picture, and you want maybe to override some behavior that the compiler is coming with. You can use type assertion. This as is so powerful. For example, this is it takes a string. If I say ages is equals to 10, automatically I'll get the TypeScript error. Type string is not assignable to type number. But assuming for whatever reason, I know that this is it's correct in my code, I can just come and do as string. Type number, it's still erroring out, but basically this is the syntax. I can't think about like a way of using it right now, but yeah, you basically assert that this is the type that this particular variable will have using the as keyword. Let me try to see whether I can get an example from what we have. But as you saw, like I used it as const that other time, and it was working. But now here, it's not working because strings are able to type number. The compiler is a bit strict with that. But if I come here and say string, just to try and satisfy it, I want to see whether I can cast it as something else. Not as const. As void, it will complain automatically. Void is not a symbol type. So this is the TypeScript compiler. Sometimes you have to fight it. Sometimes it's your friend. It definitely wants you to write better code, more robust code, and all that. So I think the final thing, this is what I've been doing here is very rudimentary. This is not how you're supposed to write TypeScript, like using this TSC directly. So if someone doesn't know how to create a project, I'll just finish with that. You can use Vite to create a TypeScript project like this. Create Vite, enter. TypeScript basics. And then you just come here, vanilla, and then you specify the language as TypeScript. And then it will basically create it for you. And then voila, you already have a TypeScript project. Like, yeah, there's a good example of type nini here. type assertion. Let me show you guys a very good example of. Let's just delete this. That's the last bit I've finally gotten an idea of. So if you, let's delete all this, maybe const up like that, or null. So if I try to access something on app, I get this error. App is possibly null, but I know that app exists, right? Because in my HTML, we have this app ID, but the compiler is a little bit too jittery and it's telling me that this one does not exist. So you can basically come in with this bang, the bang thing, this one. This just tells the compiler that this thing is not null, it's not null. Where is it supposed to go? As you can see now, it's accepting. But you can also, I think you can say as const. You can also use as, as, what is it? It's a div. HTML div element. Or you can just say HTML element. You see, as, like, this is a perfect example of the type assertion using as. Yeah, like I already know that this thing exists, but TypeScript is saying it's saying that it's null. It might be null, but I know it exists. So I'm just saying that just treat it as a HTML element, or treat it as a HTML div element. Will also work like that. But without these types, the compiler will not be happy at all. And then it's giving me just random things. But if you specify the types, as I told you, this is also a generic type. If you see double, like angle brackets and something inside it, that's what we call generic types, generics. Yeah, so I think we've looked at, someone can actually get started today with TypeScript if they want. We've looked at the very, very basics and how to use the TypeScript compiler and how to just assist you as you write TypeScript. And also, if you come into a situation where you need to like change a certain behavior, for example, in this case, you can just use type assertion. But it's actually pretty powerful. You have to use it if you know like how it works. I think that's it. Questions? We've gone above time, but yeah, at least we've covered everything. Someone has a question? Then back to you, Ian.
Okay, that was very well done. I think I also learned a lot of things today. Because I've encountered that issue of you're trying to use an element, but TypeScript is complaining that it might be null. Okay, yeah, that's very informative, and I think we all enjoyed. Okay, personally, I think I really enjoyed the session. Thank you very much, Joseph. We have gone. Yeah, it was very nice. Yeah, it was very nice. I think I learned a lot.
Yeah, so just like I should now be an evangelist. I'm actually a TypeScript evangelist. Going forward now, encourage people to also use it. It's a nice tool to have.
Yeah.
And at least automatically write better code.
Yeah. So mmesikia Pastor Joseph amesema mtumie TypeScript. You use TypeScript in your workflow.
But see, we've just been writing JavaScript, right?
Yeah.
Just the difference was just the types.
Yeah.
Nothing else that is different, just the types.
Yeah.
And you can just go and tell people you know 2 languages tomorrow.
Yeah.
They only know JS.
Mi niko na swali. Okay, so Joseph, you're advocating for the use of TypeScript. What are some of the advantages of using TypeScript over vanilla JS over frameworks like Vue or a library like React. Okay, you can use TypeScript with React. No, I don't know.
Yeah, TypeScript basically it's not replacing any framework.
Yeah.
Like it makes you write better code, more robust code with those frameworks. But it's basically just a replacement, sort of a replacement for JavaScript. Like whichever place you write JavaScript, you can write TypeScript. You can write TypeScript with Node. You can write TypeScript with Express. You can write it with React. You can write it as plain vanilla TypeScript. Yeah, whichever. Like as long as you're writing JavaScript code, you can use TS. And the advantage is more robust code. Like you have compile time type safety because your types were checked.
Yeah.
Like you have runtime type safety because your types were checked during compile time. And then the docs, like the documentation bit, you saw like using a string, maybe in an interview, you'll get all the methods if you've typed that variable as a string. And if you like try to do something that cannot happen on a string, you automatically get errors. Like it's just trying to make you write just nice and good code. Yeah.
Yeah, even Fred, VS Code uses TypeScript for
okay.
Yeah, for like auto completion. That's how it's able to tell it a value that if it's a string value, it knows it needs to give you that to uppercase and such. When you give it a number value, it needs to give you different methods because it knows the types. So it's like you've written low-level languages like that are statically typed, like C++.
Yeah, C.
And C. So the thing with JavaScript, it's not that, like at face value, it doesn't look like it has any type checking like by default, but it actually does. The problem is it's too late because JavaScript sits at the top, and then in your JavaScript there's a C++ application, right? C++ is statically typed, so C++ will catch that error at that time. So if you try to, for example, do a to uppercase method on a number, you will not see it in your code when you're writing the code. You will see it after you run the code. So when you run the code, C++ is the one that will know that you made a mistake. You cannot call the to uppercase method on a number. That's what Joseph means by they catch those errors at different times, right? When you're not using TypeScript, the error will still be caught, but it's too late. At that point, you've already run your code. Kama ilikuwa ivunje vitu in production, ishavunja. Because you caught it after you pushed your code because you were not able to see the error as you're developing the application. But with TypeScript, since you've given it explicit values, you're telling it, make sure that this particular thing is a string value. If you try to give it something else, it's going to complain before you run the code. Like you'll see the error in your Visual Studio Code. Like that's the benefit now. That's because the most common errors that developers make are type errors, like you passing the wrong types, especially for dynamically typed languages. So the benefit is there. You get to see catch your errors before you execute your code.
Oh, the Sasa. Okay, I know maybe this is comparing across languages, but how robust is TypeScript compared to Java? Because even Java is statically typed.
Yeah, Java is definitely statically typed. But if you've looked at the syntax and like it depends, basically it depends what you are doing. But yeah, if we are doing web and we're doing backend and we're using JavaScript right now, it makes sense just to pivot to TypeScript because as you've seen, it's just JavaScript syntax with types. Like I don't need to learn anything else. But now if I wanted to like write in a different language, I could go now and start learning Java, which is like it's pretty hard to learn Java. Yeah. So like TypeScript for a JavaScript developer, you should automatically consider if you want to get a job that is like in some company or anything, startups or even big companies, just learn yourself some TypeScript. Most of these companies use TypeScript nowadays just because of that. The robustness of the code is so robust compared to the JavaScript alternative, as Ian has just said, because of that compile time versus runtime type safety.
Oh,
Yeah.
nice.
So maybe to finish off, maybe I'll share a link with you guys. Just go and read the TypeScript handbook from the TypeScript website. That's a good place to start learning it.
Now one
And
last question.
then,
Hmm. Oh,
yeah, go
yeah.
ahead.
I just wanted to ask, like, is it a must you learn JavaScript before you go to TypeScript? Am a TypeScript is just a language by itself that you can just learn it without ever going through JavaScript?
It's a language by itself, but learning it without learning JavaScript will be a bit. I think it's a bit counterintuitive because like you need to learn JavaScript and know its weaknesses. I think that's a better roadmap. Learn JS, know its the weaknesses that a dynamic language like JavaScript has. Know the differences between a typed and dynamic language, and then now after that, now you can easily just pivot to. It's so easy to pivot to TypeScript because it's just the syntax of JavaScript, and the alternative is that now you have two languages on your belt. You can go and apply to JavaScript roles. You can go and apply to TypeScript roles, and most roles nowadays will see that TypeScript like added advantage or TypeScript what like whatever those positions are advertised with. But yeah, from my experience with the industry, it's a tool that it's worth dedicating some time to learn because actually it also has a very nice like tooling ecosystem, like tools like TRPC. Go and look at TRPC. It's a full stack framework whereby you have type safety like on both ends. You can write a function on your backend and then just access it with types and everything, type safety on your front end. That's a tool called TRPC. It's a TypeScript tool. Another one, Prisma. Prisma is also a TypeScript tool. It's an ORM. Basically, it replaces writing like plain SQL. It's written in TypeScript. What else? Another one that I can Remix. I don't know if you guys have heard of Remix Run. It's a full stack JavaScript framework. If you use it with TypeScript, you'll enjoy. It has a very very good developer experience with TypeScript, among many other tools. Yeah. So it's worth learning. Yeah, Ian, I can go ahead.
Yeah, and also it's also worth mentioning like what are some of the are there any disadvantages to using TypeScript over vanilla in your experience other than you have an extra step of compilation now. So normally when you run your vanilla JavaScript, you're only compiling it like during runtime. But now when you're using TypeScript, there's that extra step because now you have, before you can run your code, you have someone in the middle. The compiler sits between like your between your TypeScript and your vanilla JavaScript. So the compiler will check whether you've written like valid JavaScript, valid TypeScript, if you're using the right types and so forth. So Joseph, do you think what are some of the disadvantages maybe of using TypeScript over using vanilla?
Yeah, so definitely there's a bit more overhead when you're writing code because you sort of have to write extra code. You see, the types are so you'll definitely write more code. And then with a compilation process, definitely there's a small time element, but you'll only feel it if you have like a super massive project with 100 or 200 like TypeScript files that need to be compiled down to JavaScript. But definitely the benefits of it outweigh the disadvantages, but it definitely has some disadvantages. And another advantage of it, it doesn't have such a steep learning curve when you're coming from JavaScript. But out of top of my head, the disadvantages that I can think of, one is the small time factor. If you have a very big project, because you have to type check all those files and convert them now from TS to JS. But we also have tools for that. We have like bundlers and all that. But it's maybe a small time factor. Maybe compiling your project in a couple of minutes instead of maybe seconds, or just a difference of a few minutes. And then also the additional things that you have to write, the additional types that you have to write now on your code, but these types are necessary to make it robust. So it's sort of like win-win. Yeah, Ian.
Yeah, I guess we can end there. Otherwise, we'll talk forever. You're welcome.
Yeah, so yeah, you guys just go and learn this thing. If you feel you know a bit of JavaScript, probably you can even put it in your roadmap. Maybe a couple of months when I'm feeling a bit confident with JS, I can now try to go through some TypeScript. And for React developers especially, you have to know Java. You have to know TypeScript. I mean, you just have to know it. Like if you want to secure these jobs and all that. But you don't have to start learning it tomorrow. Or if you're still new in JS, just put it in your roadmap and know that it's a tool that exists. Don't just forget that this tool ever existed. Just know what it's supposed to do, the difference between it and JS, and plan for it down your path because it's definitely worth it. I also had that resistance in the beginning, but once I got to understand how it works and what it's giving me and the tools and ecosystem around it, I've never gone back. I rarely like do main.js, always TS or TSX. That's it from like for me because of the benefits that I've seen personally. So I encourage you guys to take a shot.
Okay. All right. Let's end there today. Definitely have a look at the resources that Joseph has shared. So we'll end. You guys enjoy the rest of your evening, and tutapatana tomorrow. We'll meet tomorrow. Have a good night and thanks. Bye.
Bye.